binary value of an int into the actual order string of that int?
No, you don't need that. You do not need that. Alrighty. Well, it is 1 o'clock. I'm gonna get started here. Double check the recorder is on first. Alright, so it is recording. Okay, the voice is getting recorded. Screen is always getting recorded. So the first thing is to answer any questions regarding the homework assignment. Okay, so remember, you are only allowed to change one expression. Okay, the zero of the return can be changed. That's the only thing you can change. But what you can change it into, that's entirely up to you. You can change it to 1, which probably is not going to work in general. Or you can turn it into something that involves like different types of operators nested in a particular way, and maybe even a call to the function itself within the expression. Okay, so that's basically how you want to approach the problem. Yes, if I can answer your question.
Yep. Just finding a way to get any representing binary equation.
Well, there are binary operators, so there's no need to change. There's no need to do base conversion because internal to the computer, the integer is already stored in binary. Okay, so what you do need is to use certain operators that can work on, the binary representation of a number. Okay, there are certain operators that are definitely, the bitwise, operators. So those would basically look at a number from the binary perspective and perform the operation on a bit-by-bit basis. So some of those operators may be useful in this homework assignment.
The question is, is there any means to get a bitwise operator and just regular division operator to work together and have it?
Of course they can work together.
I guess
a bitwise operator is just, a bitwise operator. So if you're doing bitwise AND, the result is just a bit pattern, right? And that bit pattern can be interpreted as a value that you can divide it.
Just more of an example than saying like bitwise not,
okay,
any value, and trying to feed that into just a matrix equation.
Okay, the result of any bitwise operator is just an integer. Okay, so as far as integer division is concerned, the slash is concerned, it just needs both sides of the division to be integers. So the integer value can be coming from the result of a bitwise operation, can be coming from a constant, can be coming from a arithmetic operation. It doesn't matter.
So bitwise just gets converted back into the expression.
Well, the bitwise operator does not do any conversion. It works on the values. Okay, it just works on the values in a particular way. Like, it will look at each bit of the number and work with that each bit individually instead of the whole number.
Compartmentalize it a bit, I guess. So after bitwise is done, it's basically performing what operation it has, then the value itself will just be read as a regular integer value from whatever binary it's like.
That is correct. The result of bitwise operation is just an integer. And you can use that integer at any place that expects an integer. Yes?
We're supposed to be, we can only add something to the function, right? We can't.
Okay, let me just pop the homework assignment up. So this way you can look at the actual description. And this one is, I don't even have it here. Oh, right, because last time I downloaded it into someplace else. It's not divide, it is actually in the previous one. Oh, no, it's the next one. Should click this one. There we go. Okay, so it's called bit counter. And I'll just go ahead and download this file. Well, I guess this will work. So the description of the homework is actually in the file itself. It says right here, your job is to change the value returned by the return statement. That's the only thing you can do. In other words, change this 0 into another integer expression. So you cannot change the prototype of the function. In other words, this part you cannot change. You cannot add any new parameters. You cannot remove the existing parameter. You cannot change main. Okay, so if you look at main, this is basically the code that you have to work with. So the only thing you can do is to replace this 0 with an expression. But there's no limitation of how complicated that expression can be. So that expression can involve, nested expressions, involving addition, subtraction, and multiplication, bitwise and bitwise or, and so on.
It says your code cannot include any new statements.
You cannot introduce, yes?
So it's a no if else statements, right?
No, no if else statements. No if, no else, no for, no while, no do, no switch.
What about the limiter on the number? Do we have to put in our calculations that if you put like a number like in the thousands, that it has to calculate that number for bits? Is that gonna get very
The range of values I can give you can go from 0 to the largest value of an unsigned 32-bit integer.
Okay.
So there's no actual limit of the value I can give you for testing purposes. Yes, go ahead.
Maybe this is a review for a lot of people, but where do I go in the Moodle information to figure out what this uint32 underscore t is doing to the n parameter?
Okay, very good. That's a good question. It's a legitimate question. This is a type. It basically says, it is a 32-bit unsigned integer. That's all it's saying. So as far as you're concerned, it is just an integer.
Unsigned, is it uninitialized?
No, unsigned means it can only represent non-negative values. It has to do with negative values having the most significant bit set, and it does have some strange behavior when you try to apply the method that people usually do with this code.
Okay, and where can I read more about that in the code, the Moodle?
That's a good question. I may or may not have it in the content already. Let's see.
So this is just limiting the integer to a 32-bit number.
That is
even if it
unsigned.
means 0, 0, 0.
Right.
Okay.
Yep. The actual truth is, it would not even impact if you use the operators correctly. It will still work. Okay, even if it's signed or unsigned, it should not make an impact. But this way, it is actually easier to work with. Any other questions? How many people have started on this homework assignment and start to try to put all the pieces together? Okay. Okay, very, very few. Okay, so that's not very encouraging. Because this one is not easy, okay? It is a simple homework assignment, okay, in the sense that you only have to specify one expression. But that's also why it is hard, because you can only use expressions to do it. Yep.
Can you give me a hint? Because I'm doing the ternary operator.
Yeah?
And why I was asking about the size question
Yeah.
is, depending on the number, you could have...
It does not really matter, because regardless of how wide the integer representation is, there's one value that is always giving you the same result, regardless of the width of the integer. Okay?
I got it.
Okay, so the base case is that, okay, you stop recursion when you're dealing with this value, go like, oh, I know the answer right away, I don't need to know the width of the integer anymore. Yep.
If you say we can't add any statements to the, was it a main? No,
Okay,
we
how
can't
about,
add any statements to the function. Does that mean all the expressions have to be done in the return?
yes, this is the only part you can change.
This is the return statement.
Yes, you cannot add or delete any code other than changing this expression to something else.
So is it, when you do C++, you could basically do your expression in the whole return statement without putting any statements within the body? I mean,
You
is
do
there
not
any,
need statements.
Is there anything that can't be done that you can do with you can't do multiple expressions on a return value?
Yes, you can. You can use a comma to separate things.
So is there nothing that you can do, everything you can do in one return statement expression you can do within the body of the function?
I'm not getting
If
the
you
question.
can link expressions with commas on the return line, is there nothing that can't be done just on the return line that you can do in the body of a function?
You cannot do loops. That's the only thing a single expression cannot do. You cannot do loops. But that's why we have recursion, because recursion is basically another way to perform repetitions. Yep.
Could we use go to?
Nope. Nope, because you cannot use a goto in the middle of an expression. So the restriction of you can only change this one little expression of 0 to something that is your answer basically rules out the use of gotos. Yep.
Where was recursion in the reading material?
It's just a function call. You know, it's in the inside functions and returning a value.
Okay.
Because because recursion is no different from a normal function call and a normal return from any function. Yep.
When you bit shift variable, is that bit shift value saved to it?
Say again.
When you take the value of a variable, bit shifted.
Yes.
Is that shifted value then saved to the variable?
Not normally, because bit shifting is nothing more than an operation. So the operator gives you the value of the shifted value, right? But it doesn't do anything to the variable itself.
Okay, so without assignment, it's just.
Yeah, it doesn't. Well, you can attach an assignment to it, so it becomes what we call a. Remember the name. It is a something assignment operator. Compound assignment operator. So you can do a shift with an equal, then it will actually change the variable on the left hand side. Okay, just like plus equal to, you can say greater equal to, that will actually change the variable on the left hand side. But I'll give you a clue already, you don't need that. You don't need the compound assignment operation in this case. Yep.
Could you show us a couple of examples of using the bit shifter? Just to
Okay,
get this
absolutely. In fact, I'll give you something even better. Okay, I'll give you a spreadsheet that might be helpful. So let's go to a spreadsheet here.
I'd like to see the syntax of it.
Oh, the syntax of.
Use the bit shifter.
Okay,
being
sure,
used.
we can do that. All right, so this won't help, in this case. So I can show you a sample program, using the bit shift operator. Okay, so let's go ahead and write a program to do that. So we'll do a, I don't know, shift.cpp. Okay, that's it. So uint32_t. Now this is not a type that is built into C++. So in order to use this type, you have to have an include file to deal with this. And the include file is stdint.h. It stands for standard integer.h. So it defines all of these macros, it defines all of these names, so that we can now refer to uint32_t as an unsigned 32-bit integer. So we're not going to do the recursive one, so we'll just do a main here. And what we'll do is to do some experiments. Okay, so we'll do a uint32_t xyz. And we'll say x equals to, let's say 32. And we'll say y equals to x right shift by 1 position. And we'll say z equals to x left shifted by 2 positions. And return 0 at the end. Okay, that's it. This is the entire thing. So what we'll do is we'll go ahead and compile this code and see how it works. sg shift.cpp. Link it, and now we can look at the program. Put a breakpoint on line 7. Okay, run the program. Single step. Okay, so now we know x is 32. So print x. X is 32. One thing you might find useful when you're debugging this type of program, your homework assignment, is to learn how to print a number in base 2. Okay. Now I did that once already, or at least once. in the previous class. Okay, I will see if anyone remembers how to do that. How do you print a number in base 2? Okay, the answer is okay. So first of all, if you don't remember how to use print, just say help print. Okay, if you remember, yeah, I kind of remember we can do something like that using print. So you can say help print, except help print refers you to X, the X command here. The expression may be preceded with /fmt or format, where format is a format letter, but no count or size letter. See X command. Okay, well, we never talked about the X command. How do I know? So how can I learn about the X command? Help X. Okay, so now we are reading about the help of the X command. Okay, which is X/fmt. FMT stands for format. Format letters are O for octal, X for hexadecimal, D for decimal signed, U for decimal unsigned, and guess what? We now have the answer, T for binary. Okay, so print /T will print the integer in base 2 in bits. Okay, all right. So this is exactly what we'll do with this program. Print /TX. It shows you in binary 32 is 1 followed by 5 zeros. Does that make any sense to you? Is 32 2 to the power of 5? It is. Okay, great. So that works out okay. Now we single step. Now y has a value. Okay, let me just list the program again. List on line 8 or surrounding line 8. So when you look at line 8, y is x shifted to the right hand side by 1 bit. Okay, what does that mean? If everything is moved to the right hand side, what happens to the rightmost bit in X? It falls off. Okay, it goes into the trash can. But what is shifted from the left hand side? A 0, exactly. So what bit pattern should I find in Y at this point?
0, 1, and 4 zeros.
4 zeros instead of 5, okay? Because the least significant 0 got shifted out of the number, and the new 0 is shifted in as the most significant bit. Okay. So print Y is 16, which makes sense because 2 to the power of 4 is 16. But more importantly, in base 2, it is 1 followed by 4 zeros. Are we doing okay so far with this? We are now going to track down the last statement here, which is X shifted to the left-hand side by 2 bits. In other words, this time I'm shifting in 2 zeros from the right-hand side, move everything by 2 places to the left-hand side, and then the most significant 2 bits will be lost because they are shifted out of the number. Okay? So how many zeros are we talking about? X still has 5 zeros, so we should be looking at 7 zeros. Okay, 1 followed by 7 zeros. Okay, so we'll single step print Z. Well, print /T first this time, and you can count. We have exactly 7 zeros. Okay, but what value is this binary number representing? 2 to the power of 7, which is 128. Okay, so let's double check. Okay, so print Z all by itself is 128. Are we doing okay so far with this? Okay, yep.
Yeah, I can't find in those functions and then call functions. Recursion is only mentioned in passing in the very first.
We actually talked about it in class as well last time. So if you checked out the video that I captured last time, there's actually a specific debug session using GDB to visualize what happens when you have recursion. Okay, but the main point is recursion is no different from any regular function call. That really is the whole point. Recursion is a function calling itself, but otherwise it's just like a function calling any other function. The same mechanism, the same thing happens.
So a recursion is just a function calling itself?
Yeah.
Inside itself?
Yeah. But the mechanism of calling and the mechanism of returning does not change. So it's still using the same method or same mechanism of doing everything. Okay, are there any questions at this point? So I think your question is answered, how to use the shift operator. So it's really just, two greater than symbols or two less than symbols, depending on which way you're shifting. The only thing you have to be kind of careful about is don't put a space between the two greater than or the two less than symbols. That's the only thing. They have to be together. Okay. Any other questions? Go ahead.
I'm still really confused about the program itself. You have the top part where you have X being initialized as a 32-bit number, and you return 0 of the homework assignment.
Okay. Okay, so this is the homework assignment.
You're saying that you want us just to change the 0?
Yep.
So the bottom half, are we supposed to be passing in X for that?
The bottom half, you mean in main?
Yeah.
Well, in main, we are passing n, and n is getting its value from this assignment statement. So in this particular case, we are passing 33 as a value to the subroutine. And what should the subroutine be returning in this case? How many bits of 1 do we find in the value of 33, or the binary representation of 33? 2 bits, right? 2 bits of 1 inside 33. So when we return, the variable bits should get a value of 2. So the way I set up my script is I will put a breakpoint right on this line here before you call the subroutine. And my code or my debug script is going to change n to some test value that I will use to test your program. I would also set up a breakpoint here, so when it returns, my script will check whether bits has the correct answer. That's how I'm going to grade this particular homework assignment. Is that making any sense or not? Do you want me to take a look at a sample of the script that I will be using to test your program? That might be helpful, because you guys can replicate that and use it to test your own program. I'm not going to give you the exact test cases that I'll be using, but with this particular homework assignment, if it works for 0 and work for, well, 1 is kind of trivial, but if it works for a few values, it's going to be, most likely it's going to work in general, okay? So let me just give you an example, okay? So I'll give you, my test script will look like this. So it will first put a breakpoint at main : stop here. Put another breakpoint at main : check here. Then it's going to run the program. When it gets to the first breakpoint, which is right before the function is called, it's going to use a set var. Okay, it will change n to some test values. So let's say I change it to 207. Then it will continue execution, which will go into the subroutine that you are modifying. It will return with a value. It will be stored in bits. When it comes back and stop again, it is time for me to check bits. So I can, basically just say print bits to see what the subroutine is returning. So this is how I'm going to grade your homework assignment, is to give it multiple test cases. Okay, so 207, maybe 250. I'll just give it some representative values to check, and let's just play with this. Okay, let's just do this and see what it does. Yep.
Is X not going to be a negative number?
X cannot be a negative number because it is a unsigned 32-bit number.
Okay.
I specifically want to avoid negative numbers, because when you're dealing with bit shifting, negative numbers will shift ones into the number, and that makes the problem a little bit harder to deal with. So I don't want to deal with that, and so I just say, okay, let's not deal with negative numbers. It's impossible to store negative numbers in this case. So this is how I run the program using my script, and this is what it does. And let's see, what is it? Continuing. It doesn't print anything. Okay, so let me just revise the script here to print bits and see if that works. No bits in current context. The programs got out before. Okay, I'll have to do it by hand first. Okay, put a breakpoint at main : stop here. Okay. That's because I used the wrong label name. Okay, start here and check here. Okay, there we go. There we go. All right, so GDB main redirect test.gdb, and that's, so this is the value that is returned, and I'll be using this value to grade your homework assignment to see if it is what it is supposed to be. Are there any questions about the homework assignment? What the program is supposed to do? Let me just give you a few examples and see if you guys can work on those by hand. Okay, that's the first thing I'm going to do, is just deal with these numbers by hand. This is why a spreadsheet can be helpful. Okay, so we'll deal with 207. Okay. All right, you look at 207. Remember last time we talked about the least significant bit, which is easy to check because if the number is odd, the least significant bit is a 1. If the number is even, the least significant bit is a 0. Okay, so it's always very easy to check just one bit, the least significant bit. Okay, so we look at this number and we say, is it an odd number? It is an odd number. So as far as I know, it has at least one bit that is of a value of 1. Okay, great. I have done my job. Okay, but what about the other values? Well, I'll leave someone else to process it. How do I get to the rest of the value? Everything other than the first bit, I want to shift the first bit or the least significant bit out. Then I will let somebody else to process the rest of the number. Okay, so how do I do that? What do I do with 207 to get rid of the least significant bit and shift everything else to the right hand side? There are several ways to do it. I can do the shifting, or I can just do division, right? So what do you get when you divide 207 by 2, not counting the remainder? 103, okay, so 103 is the next number that I'll be working with. And then you ask, is 103 an odd number? Okay, it is odd, so the least significant bit of 103 is also a 1. So as far as this invocation of the subroutine is concerned, it counts one bit that is of a value of 1. And then you divide 103 by 2, okay, we get, what number do we get? 51, right? Not counting the remainder. So the question is 51 an odd number? Yes, it is. Okay, so we put a 1 here. Then we have 25, right? 25 is an odd number. 12 is not an odd number. Okay, so as far as that invocation is concerned, it did not find a bit of a value of 1. Okay, the least significant bit of 12 is not a 1. Well, but I cannot stop at this point because 12 itself is a non-zero value. So I cannot stop because there might be some other bits too that are not the least significant bit that are actually of values of 1. Okay, so what is the next number to process? What is 12 divided by 2? 6. Okay, 6 is an even number, so we cannot count a 0 there. 6 divided by 2 is 3. It is an odd number. 3 divided by 2 is 1. 1 is an odd number. And 1 divided by 0 is 0 with a remainder of 1. And at this point, I know I am done. Okay, because if the value that I'm supposed to process is 0, does it matter how many bits is used to represent 0? I can use 4 bits to represent 0, then I have 4 zeros, right? I can use 8 bits to represent 0, then I have 8 zeros. I can use 64 bits to represent 0, then I have 64 bits of 0. There are no bits of 1 in 0, regardless of how many bits I use to represent it. Yes?
1 divided by 0 is undefined, it's not 0.
But I'm not dividing it by 0.
What are you dividing 0 by 1?
Yeah. I'm not, there's no division by 0 or division by 1 that I have mentioned up to this point. There's only one value that I use as a divisor throughout all of this stuff here. So now what happens is this last invocation is gonna reply to the previous invocation and say, hey, I did not count any number. So the return value from the second last invocation is going to be the 1 that it found plus the 0 that is reported by the following invocation. So this value in return becomes the value it returned to this invocation. This invocation said, I found 1 bit of 1. Let me see what the other guy found. Okay, so it will include this 1 plus the return value of the next invocation. So now it has a value of 2. And then this guy would do the same thing. This guy says, I found 0 bits of the least significant bit that I was supposed to process is 0. Okay, I do not see any bits of 1. But let me ask the next guy. Okay, the next guy said there were 2. So now it becomes the sum of this number plus this number. And then this guy is the same way. Okay, so oops. This guy would say, this number plus this number. And this just keeps going. So I'm going to use a spreadsheet trick here. So the final answer is a 6. It will involve, let's see, the first, okay, let's count the number of invocations, okay? 1, 2, 3, 4, I mean, you can definitely see, it has 9 levels of invocations to the bit counter function. The key part here is, when do you know you can stop, okay? And what do you return when you know you can stop? You kind of have to put all the things that I talked about together, okay? This is not going to be one of those things where, oh, this is just a chore, type of programming assignment. This is the one that, where you have to put all the things together, make connections between all those things to make it work. Okay, are there any questions? Okay, let me just give you one more example because I know that we talked about this already, but I'm gonna do this one more time. This time it's about factorial. Okay, you guys still remember factorial? All right, so let's start with a factorial of 4. Okay, so we start with 4. Okay. Well, I'm too lazy to find out what is the factorial of 4. So I would say, well, the factorial of 4 is 4 times the factorial of 3. So the next problem I have to solve is the factorial of 3. Then it becomes the factorial of 2, the factorial of 1, and then it becomes the factorial of 0. Okay? Let me close the door. Now, what is the factorial of 0? By definition? The factorial of 0 by definition is 1. Okay? So I can stop at this point. I don't have to ask that question. I don't have to ask another person, what is the factorial of -1, because by definition I know the factorial of 0 is 1. Yep.
This is good, but in GDB, how would you change the variable for n before it enters into function use?
Set var n equals something. But you have to do it while the program is running. So you might want to review what I did, not only today, but also last Wednesday, because I used the same method on last Wednesday as well. Okay. All right. Now that we know the factorial of 0 is 1, what is 1 times 1? Well, 1 times 1 is 1, okay? But I'm not going to just type 1 here, so I'll use an equation to do that. And then to this guy, back to this guy wants to calculate the product of 2 and the factorial of 1. Well, this is the factorial of 1, this is 2, so this becomes 2 times the factorial of 1. And then when we get back to this guy, then it is 3 times the factorial of 2. We know the factorial of 2 is just 2, so it becomes 3 times the factorial of 2. And then when we get back to here, finally, then it becomes the product of 4 and the factorial of 3, which we know is 6 already. The code of factorial is already done. Okay, that's what we did last Wednesday. Okay, so the important part is what I do in class is something that you have to study. Okay, it's not just me, yakking along, talking about stuff. That really is part of the material that you have to review. I mean, that's a lot of the content is this part. Is that okay? And that's why, having a piece of paper, a notebook, or something to take notes during class is going to be helpful. But Tech, you're doing screen recording already. Why do I need my own way of taking notes? 2 reasons. One, bad things can happen. Murphy's Law. Okay, the one video that you really need the most will have a technical difficulty, and it turns out to lack the audio part, or somehow the file is corrupted. So don't count on it 100%. 2, I cannot speak what you are thinking. So when you look at the code that we are going through and something just occurs in your mind, you make a connection, you say, oh, this is related to the homework assignment, then you want to write it down, because I do not know whether you are thinking about that or not. Okay, I cannot record that part in my own video. You can do it on your own piece of paper, and that's why taking notes is important. Are there any questions about this part? You have all the pieces. The question is, how do you put all the pieces together to make this program work? Okay? Let's go back to the homework assignment. I'll give you one more clue. Okay, I'll give you one more clue by looking at this program. Okay, so I'm going to, remember the name of bit counter, right? Okay, bit counter is just bit counter. It's supposed to return the number of bits in a particular integer. All right, so let's just say this is all in comments, so it's not really a part of the program. Okay, so if I say, I don't know, xyz as a variable equals to bit counter, I'll give it some gibberish value here. Okay, what is going to be stored in xyz? To be more importantly, what is the expression on the right-hand side going to return?
Whatever you put in your return value on your function.
No, assuming bit counter is already implemented correctly, what is this going to do? What is the right-hand side? What is the value of the right-hand side?
The kind of function returns when it comes in.
It'll be the number of bits that are ones in the binary representation of 49,171, right? Because that's the definition. That's what I want bit counter to do. Is that making any sense? Okay. So when you look at your own homework assignment and you say, well, I already know this number is an odd number or a even number, okay? So the least significant bit is taken care of. You look at the rest of the number. Who are you going to call to ask how many bits of ones do we have in that part of the number? Not the Ghostbusters. Bit counter, right? So that is the key to get this homework assignment done, is to understand that when this is all implemented, bit counter will tell you the number of bits of 1 in a particular value. So use that. Okay? Use that assumption to get your homework done. It will involve recursion.
The recursion is all explained in your last lecture.
Yes.
Okay.
Were you here?
I was here. I was doing other homework, sadly.
Well, that explains it, doesn't it? All right, I'm going to pass the roll sheet. I didn't do quite the dramatization of Doctor Who, like, well, David, what is his name? David Tennant, that's it. Yeah, he is very dramatic. Yep.
In GDB, what do you, for the recursion there, what variable would we be checking at the end to make sure it doesn't actually
It does not do that, does it? That would be a little bit of a problem. So what you need to do in that case is to start with simple test cases. Okay? Okay, let me answer that question in a slightly different way. Okay? So he has a really valid question. What should it? Sorry? Kodiak?
Yes.
Okay. Okay. Like the bear. Okay, so Kodiak has a really good question. Okay? So how do we check in GDB, whether it is returning the right value or not? Okay? That's a very valid question. So what you want to do is not to rely on that aspect of GDB to help you debug this program. Instead, you can change the way you test the program to make it work kind of the way you want it to work. Okay? So I will give you an example. Okay? Of course, it's difficult to give you an example without disclosing the solution. So I'm going to give you something that is something you have seen already. This is actually good. Okay? So I'll give you Factorial. Okay? I'll re-implement Factorial so that we can use it as an example. Yep.
Factorial was the last lecture as well?
Yes, it is in the last lecture. So I will basically do this one here and say, return. I think in Factorial I gave you the solution in ternary operators already, didn't I? So I'm going to do that. Okay, so we'll say if x is less than or equal to 0, return the 1, otherwise return the f of x times the factorial of x minus 1. Does that look strangely familiar to you? It should be, okay, because this is what we did the last thing on Wednesday last week. Okay, so I know it's 5 days ago, 5 days is a long time, but this is what we did last time. Okay?
Was this a homework assignment or anything?
No. This is an example that I used in class last Wednesday to illustrate recursion, how to use GDB to check out recursion and stuff like that.
That's Wednesday. Sorry, I forgot today. I thought today was Wednesday. Apologize.
Okay. So with this one, we'll set up the same way. Okay, so we'll set up an n here. We'll say n equals to the factorial of. Well, that works too. Okay, they don't have to be in the same variable. All right. So we'll set it the same way using two labels. Start here and end check here. All right. All right. So this is resembling your homework assignment a little bit. Okay, it's a different type of problem to solve, but it is resembling the homework assignment. So now the question is, how do I know f is returning the correct value? That is your question, right? Okay. Yep, go ahead.
I was just thinking, as we're writing our code, I know you don't want to add anything other than the one statement, but are we allowed to add labels to help debug it later on, or?
When you turn it in, you cannot have anything other than changes to that one single expression. Adding comments is always okay. Okay, anything that is not code is okay. So comments is code, but the only change to code that you can do is to change that one single expression. Now, when you are debugging, I don't care what you do.
Okay.
Okay, so you can use magical statements that I don't even know of in C++. You can use spells. You can use anything you want. But when you turn it in, I would use whatever you turn in for grading purposes. So when I look at that program, you can only have changes to that expression.
Okay.
So you will have to undo all the things that you're not supposed to have. So all the bloody parts and whatnot, you have to clean it up. Yep.
I apologize. Were the commands BT and frame covered last Wednesday?
Yes.
I'm just going to be quiet now.
That's not my intention. It's just there's a lot of stuff that we went over in the previous class, and it would be helpful to be able to watch the video again. I mean, because everything is recorded, so that might be helpful. All right, so we want to debug this program. Okay, we want to debug Factorial, and we'll do the same thing. You'll set up a breakpoint at main : start here. We put a breakpoint in main : check here. Here. We'll also put a breakpoint in the subroutine itself, in F. Okay. So now the question is, how do we know this subroutine is actually working the way it's supposed to? In other words, if I run the program and say set var n equals to, okay, this is what we don't want to do. Okay, when you are debugging the program, don't start with something that is kind of that would involve a lot of recursion before you actually get to know the result, because this is what's going to happen. When I continue execution, it will stop inside the subroutine because I did set a breakpoint in the subroutine. So if I keep continuing, it will keep doing this. But one thing you might notice is the parameter is now changing with every single invocation, which is the way it's supposed to be, right? Because every single time I get to this line of the subroutine, x is less than or equal to 0 is false because it is 15. So what do? We do not return a 1. This is the then value. We go to the else value. X times f, the factorial of x minus 1 is what we are going to return. But I cannot return that value until I know what is the factorial of x minus 1. In this case, it is the factorial of 14, right? Who am I going to ask what is the factorial of 14? Subroutine f, okay? That's my factorial function. So that's why when I run this program and I keep continuing, it will keep calling itself, okay, until it becomes 0, okay? It will get down to 0, but when it is 0, then the first expression of the ternary operator is going to evaluate to a non-zero, because 0 is less than or equal to 0 is true, and true is non-zero, which means it's going to return the then value, which is just a 1. Recursion stops at this point. Okay? So this condition is important because it tells you when we are going to stop the recursion. When can we say, oh, just by looking at the value that I'm supposed to process, I know the answer right away. Is that okay? Okay, so at this point, if I do a BT, what should I find? Okay, I'll give you two options here. One is, oh, we find that main called f, that's it. Or do we find that main called f, and then f called f, f called f, f called f, about 22 times and get to here. 23 times actually. First option or the second option? Second option, very good, okay? You chose wisely. Okay, because all of these invocations are right on top of each other. Okay, so your question is, how do we know that the function works in general? The answer is, there's no way you can know when it is like this. But there's a different way to debug your program to check it. Okay, so the trick is not to give it a test case like 23, where you have a lot of recursion. You will give it test cases where there are no recursions. That will be your first thing to check. And then you will give it a test case that involves only one recursion, one level of recursion. Then you'll give it a test case that has 2 recursions, 3 recursions, and so on. So you test the program, the very same function, but from the bottom up. You start with the case where there's no recursion. And then you work with the case there's only 1 recursion. Okay, so I will tell you exactly what it is in this case, okay? In this context, it means I'm going to start the program because I realize if I single step here, it's going to just do something like this, and I have no idea what the return values are. Okay, so that makes it kind of hard to debug a program when it doesn't show you what is being returned until the very last one, back to main, then it stores a value, right? So if I implement something incorrectly, this is not going to help me. Okay, so the other way to debug this program, and you can use the same method even though your program is supposed to calculate something different, but the nature is the same. So when you run the program, what you want to do is to think, oh, what is the case of what do I want to put into n where there is no recursion? What do you think? In this case, what is the value of n that will give me no recursion whatsoever? 0, okay, so according to the expression, 0 would do it. So I'm going to say set var n equals to 0, okay, and then I just do it, okay. In fact, I will just go ahead and continue the program. It will still stop in the subroutine, that's okay. Single step, it will get back out into main. I'm back into main at this point. So I print n, and what should I see? It should be a 1. In this case, because the factorial of 0 is 1. Okay, so in this case it is 1 because the ternary operator specifies a 1 as a constant as the second expression. Okay, so I double check that. Well, seems to work okay. Okay, so now I have some confidence that it does work. At least the base case works. Okay, the case when recursion stops is called the base case in recursion. Okay, it's just a name, just a label. Okay, nothing more than that. All right, so I'm going to run the program again to test it one more time, test it with a different test case. I don't want to do a set var n equals to 23 because that involves 23 levels of recursion. Okay, I just want to have one more level of recursion. So you guys tell me what n is supposed to be in this case. I just need one level of recursion. 0 gave me one level of function call or no recursion whatsoever. So what value will give me exactly one level of recursion?
1.
Just one, exactly. So we set it to 1, then we run the program, continue the program. This time it will get into 2, okay? So this is a good thing to check as well, is every single time you do the recursion, you want to see whether the parameter of the new invocation is right or not. Okay, so you want to double check with that and go like, yep, it's supposed to calculate the factorial of 0, but we already know it can correctly calculate the value of the factorial of 0, right? So I don't have any question about that part. Single step, now I'm back to main, and now I can check and say, okay, am I getting 1 as the factorial of 1? The answer is yes, okay? So now I have checked this program at 2 levels of recursion. Does that make any sense? Then I move on to 3. After you check 3, you move on to 4, okay? Now, of course, you can, with this, you can move on to a lot of levels, okay? But at some point, you can get some confidence and go like, well, seems like the program is working. And you can just say, okay, we're good. So that's how you can debug a program, even though you don't know at each level what it is returning. Because you basically start with the cases where you have 0 recursion, check that first, and then you work with the test case with only 1 level of recursion, 2 levels of recursion, 3 levels of recursion, and so on. Okay. All right. Any other questions? Yep.
My code compiled and linked, but I get a segmentation fault.
Say again?
My code compiled and linked, but I got a segmentation fault. I don't know if the homework.
Does it take a long time to get to the segmentation fault?
It gets there pretty fast.
You
No.
probably have an endless recursion. So your recursion does not stop. Okay, so this is another question, okay? Some of you will get into this test, will get into this situation. So I'll show you the situation and how you can find out that really is the situation or not. So let's just say that somebody is just copying my code and did it incorrectly. Okay, that happens all the time. Okay.
I code on both sides of it.
Yep.
Yeah.
So this is definitely not a good thing, because if x is greater than 0, what's going to happen? It will call f of the same value, right? What's going to happen with that invocation? It's going to call f with the same value. And what's going to happen in that case? It will call f with that same value. And it will keep going on and on and on, because it will never get to 0. Okay? So I want to show you what happens when you run a program like this, so that when you encounter this type of symptom, you know what it is. Okay? Is that okay so far? So this is the kind of stuff that I think is really, really important in a class like this. The programming language itself, it's mechanical, but this is not mechanical. This is the part where, it really is, it requires, interaction and explaining. Yep, go ahead.
When it goes to the return, where does the computer start operating in for that recursion? I think I got it. It returns
It goes
x. If x is greater than 0, then it's going to do that calculation, and it's going to return. And what line segment of the program does the computer start to compute?
Line 3 basically returns back to line 3, but it's a different invocation, because every single invocation has its own return address.
And what's calling the invocation? The return statement? What's invoking the function after return?
It knows where to go back to, because that's the whole nature of calling. Because when you're calling, it remembers where it's supposed to go back to.
F is...
that's a function call
F
right
is the
there.
function. Oh, okay. Gotcha.
Okay, so let's go ahead and take a look at this program. And what was I about to do? I lost track. Oh, endless recursion. That's right. Okay, so all we need to do is to run this program, because it will, run indefinitely, and it will run out of what we call stack space. Because, okay, so no, it did not. Oh, that's because of the test case. Something is not right. Okay, I compiled it. I linked it. Okay, let's take a look at the program. Oh, that's because n is not initialized. Okay, fine. When n is not initialized, there's an odd chance that it might be 0. And 0 still works because if x is less than or equal to 0, it would just return a 1. So it did not get into the infinite recursion that I was supposed to get into. So I have to put a breakpoint in main start here. That's all we need. Run the program again. Set var n equals to anything other than 0 will work. 1 will work. Continue execution. Is that what you're getting?
Yes.
Okay. So at this point, not that it's really a cool thing to do. It's kind of cool, but okay. So at this point, if I do a BT, what do you think I should be seeing? Well, not quite infinite, because it's because we don't have infinite memory that we encounter this problem. So it will only show you the number of invocations before it ran out of space. Okay? So when you do a BT, this is a clear indication that you have an infinite recursion. Okay? So look at this. Well, okay, because it says you press return to continue. So the question is, how many times do I have to press continue to press return to get back to main? The answer is more than I want to do. Because the number of times that I called f before it ran out of space to store the return value, to store the return address, is a lot. Okay, it's probably in the order of at least millions.
I call it a stack overflow, then I'm joking.
It is stack overflowing, yes, because that's where we store the return the return address, where to go back to. Because every single invocation, when you call f, every single time you call f, it wants to say, oh, I need to remember where to come back to later, and then you get to the next invocation, it does the same thing. So that's why we see something like that. Yep.
Was that some joke why the website is named Stack Overflow? Do you know?
That I do not know why they chose the name Stack Overflow. Yep, but this is this is definitely a Stack Overflow situation. Now the other thing you might observe that will give you a hint that you have a logic error that is leading to an infinite recursion is take a look at parameter x. What do you notice? It did not change at all. Okay, and that's the reason why you got into the infinite recursion, because x remained the same, so it will keep calling itself over. Function f will keep calling itself over and over again because the parameter never changed. It's supposed to go down to 0, okay? Then it can stop. But since I messed up my code, it will never get down to 0, and now we have a problem. Are there any questions about debugging your recursive subroutine? Okay, all right. So I'm gonna, say this is done for now, okay? Unless someone has a specific question, I will basically, say that the homework assignment questions are all answered. Okay. All right. With this out of the way, we can now move on to. I just exposed that earlier. Oh, I exposed it to the wrong part, I think. There we go. So now we have some mock questions for exam number 1, which is going to happen next Monday. Okay, so next Monday is exam number 1. We are over by about a week or so because it's supposed to be like 1/3 through the semester. We are a little bit more than 1/3 through the semester. So we'll have exam 1 next Monday. Okay, I'll put a little entry here too. These are practice questions. Okay, so in other words, I will talk about these questions, and we'll work this out in class, okay? But this is the type of question you will get in the exam. So this is the first question, okay? I will usually present a piece of code for you to analyze, okay? And because of the nature of this type of question, I'm going to have a paper-only test, okay? So you cannot use the computer, use any computer, I should say. You cannot use any computer during the exam, but it is open book and open notes. So you can bring along, books, your own notebook, cheat sheets, whatever you want to bring in, okay? But it cannot be a computer, it cannot be interactive. All right, so let's work on this problem first. Analyze the following code, okay? And I intentionally took out all the indentations, okay? Because I want you to work out the structure of this code. Clearly, there's no indentation to help or confuse you, because if I give you the wrong indentation, you might think the structure of the code is one way, but it's actually the other way. If you think this code has a syntax error, state why there's a syntax error and how to fix the syntax error. So, okay, what do you think? Is there a syntax error in this code? Well, first of all, how do we analyze this code? How do I read this code and say, well, is the compiler going to see a syntax error or not? You have to think like the compiler, okay? That's the key. You have to think like the compiler. All right, so on a piece of paper, you might want to, okay, I'm going to use a mouse pad here as my piece of paper. So what you want to do is to work out this, and you basically want to look at this code like the compiler does. The compiler sees this if, and what is it going to do immediately? It sets up expectations, right? It will set up the expectations as follows. It will say, I want to see open parenthesis, an expression, a close parenthesis, and a statement. Optionally, after that statement, I can see an else, but after the else, I would definitely see another statement. That's what the compiler is going to think. So we'll leave all those slots here. So we'll say, okay, this is an if, open paren, expression, close paren. We'll have a single statement, which is the then statement. And then after that, maybe we'll see an else. So I'm going to use square bracket to indicate something that is optional, okay? But after the else, I would definitely see another statement. In other words, if I see the else, then the statement after the else is not optional. Okay, so else with the other statement is optional as a whole, but if I see the else, then the statement is no longer optional. Okay, to make this more clear, I'm going to set this up so that we have then statement and also else statement. Okay, so when I see the first if on line 1, it will set up the expectation of a structure like this. Okay, the compiler says, I want to see something like this. And then what does it see? Well, then it will see the open paren, okay, this open paren, and then it will see the expression, which is x is less than y. Then it will see the close parenthesis, which is this close parenthesis on line 1. And then what does it see next? It sees another if on line 2, okay? So what are we dealing with from the first expression's perspective? We're dealing with the then statement. So that means the then statement of the overall conditional statement is another conditional statement. Is that okay? So if you want to look at this code here, so it becomes if, and then x is less than y, then the then statement itself, okay, so I'll still keep this part here. I'll call this one then statement 1, because there will be others. Else statement 2 and else statement 1. Okay, while I'm expecting then statement 1, I see an if. So that means I have another conditional statement here. It will set up the same expectations. I'll call this one then statement 2 and a optional else statement 2. Like that, okay? And then what do we see after the second if? I see open paren, y is less than z, close paren, and then we see k equals 1. So that means this expression is actually just y is less than z, okay? What is then statement 2? Say again? It's an assignment, right? It's an assignment expression, but turned into a statement because of which symbol? Which symbol turns an expression into a statement? A semicolon, okay? Very good, okay. So k equals 1 and a semicolon together, line 3, the entire thing is then statement 2, okay? So that's good. So k equals 1 goes here. And now from the perspective of the second conditional statement, it is saying, well, sometimes I can see an else. Do I see an else in this case, right after the statement? Yes, we do. Okay, very good. So now we are meeting that expectation. So else, we see And after the else, I'm supposed to see another statement. And in this case, do we see another statement after the else? What is that statement? K equals 2 and a semicolon, okay? Because K equals 2 by itself is an expression. K equals 2 with a semicolon is a statement, okay? So K equals 2 is, okay, wait, hold on a second here. Whose else statement is it? Does it belong to? Does it belong to the nested, the inner conditional statement, or the outer conditional statement? The inner, because it is just like parentheses, okay? So the inner conditional statement is the one that is actively being processed. So anything that fills its expectation belongs to the inner one, the one that we are processing right now, okay? So that means K equals 2 is actually our else statement 2, not else statement itself, or else statement 1. Is that okay? Okay. So else is K equals 2. So K equals 2 is actually else statement 2. And then what do we see? We see another else, right? But before we see the else, from the perspective of the nested conditional statement, have we seen everything that we should see with a conditional statement, including the optional stuff? We have seen everything that we're supposed to see with the inner conditional statement. And what that does is it's acting the same as a closed parenthesis when we're processing expression. In other words, this entire thing, the entire inner conditional statement, which is a conditional statement itself, is now only seen as a single statement, because we are done processing it. Okay, so it is just a statement now at this point. Okay, and as a single statement, which slot does it go into? Then statement 1. Okay, so then statement 1 of the outer conditional statement is now processed, because then statement 1 becomes this entire thing. Are we doing okay so far? From the perspective of the outer conditional statement, this is now processed. Okay, this requirement is now filled. What is the compiler thinking at this point? What is after this? An optional else. Okay, an optional else. Do we see the optional else? Which line do we see the else? Line 6. Okay, line 6 is now seeing the else of the outer conditional statement. Is that okay? But after that else, it forces us to see another statement. So now we say, okay, we need to see another statement. After the else on line 6, it is filling the requirement of the optional else of the outer conditional statement. So now the compiler is saying, give me a statement. Do we see a statement after line 6? Well, we see the beginning of a statement, right? So after that, okay, I'll just put it like this. So else statement 1 is now becoming a conditional statement itself. Okay, it starts with an if. Okay, it has open parenthesis, an expression close parenthesis, a then statement. We'll call this then statement 3, an optional else, and an optional else statement. We'll call this else statement 3. Okay. So at this point, the compiler is saying, okay, I can see that expression else statement 1 itself is a conditional statement. So now I'm going to process the conditional statement. I will be expecting open parenthesis, which I see on line 7, an expression, which I see on line 7, a close parenthesis, which I see on line 7. So line 7 is fulfilling part of these requirements, because I see the open paren, x equals to y as the expression, the close parenthesis. The compiler is now expecting what? A statement. And then statement 3, okay, because I want to identify which one we are dealing with here. Do we see a statement after line 7? Yep. And what statement is that? Can someone spell that out? Semicolon. Okay, so k equals 3 is an expression. When you want to use it as a statement, you have to include the semicolon. Okay. So at this point, then statement 3 becomes the expression, becomes the statement k equals 3 with a semicolon. Okay. In other words, as far as the as far as else statement 1 is concerned, which is a conditional statement all by itself, this is done, 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 and what is the compiler thinking at this point? It's basically saying, well, you know, we can see an optional something. What is the optional thing that we can see? The else, okay? Now, the else is optional. Do we see an else? We see an else on line 9, okay? So that means this else is now found. But if I find this else keyword, then it's no longer optional that I need to find a statement after the else, right? So the compiler says, okay, I find the else, now I want a statement. After the else, line 10 is a statement because k equals 4 is an expression, but anytime you put a semicolon after an expression, it turns into a statement, okay? So k equals 4 is now the statement. All right, so looking at this big mess here, how do we read this? This is one way to do it, okay? So I can say, overall, you know, we have expression 1, then statement 1, an optional else, and else statement 1, okay? And then we'll say, oh, we know what expression 1 is. Expression 1 is y is less than, x is less than y, okay? X is less than y. And we also know what then statement 1 is. Then statement 1 becomes a conditional statement. And any conditional statement will have an expression. We'll call this expression 2. And it has a then statement 2. It has an else, optionally, and an else statement 2. Expression 2 is easy. We find out that turns out to be y is less than z, okay? And then we say, what is then statement 2? Well, then statement 2 we find out to be just a simple expression. It is k equals 1, okay? And now we say, do we find an else? Yes, we find an else at that point. What is else statement 2? Else statement 2 is just, you know, k equals 2. So we say else statement 2 is just k equals 2, semicolon. That concludes then statement 1, which fulfills this requirement. Then we see the optional else from the perspective of the first conditional statement, which means now we are processing else statement 1. So that means else statement 1 is a conditional statement, and I know that because I see the if keyword. That is what signifies that we have a conditional statement here. And this is the structure of any conditional statement. It has an expression, it has a then statement, and an optional else, and then after that we have an else statement. When we process the else statement, when we process else statement 1, we see the expression. So expression 3, expl3 is x equals y, okay? X, you know, compared to y, and they're the same. And the then statement 3 is k equals 3. So we'll say then statement 3 is k equals 3 with a semicolon. Else statement 3 is k equals 4. That is the structure of the code. Okay, now since I'm doing this using a notepad, and this is pretty much the limitation of what I can do. What you can do instead, if you have a piece of paper, this is what you can do. I cannot capture this part here because I don't really have a way to capture any drawing. So what you can do is to say, oh, the first thing we see is an if, okay? With an if, we'll set up the following expectations. Open paren, some kind of expression, close paren, and we see a then statement. Optionally, we'll see an else, and after the else, we definitely have to find an else statement. Okay, so that's only because we saw the if word, okay? As soon as the compiler sees if with a space, it sets up this expectation, okay? Then it will continue to process the data and find out, oh, on line 1, this is checked, okay? And on line 1, we also find out what the expression is. It's just x is less than y. We'll also find this one on line 1, okay? That's the end of line 1, okay? At the end of processing line 1, the compiler knows that it's dealing with a conditional statement. It finds that this part is already done, okay? So on line 2, it's saying, give me a statement. I'm expecting a statement, which is then statement here, okay? What does it see? If, right? It sees the word if first on line 2. So that means this breaks out to be something similar to the first one, okay? It is an if, and as soon as the compiler sees the if, it knows, oh, we need 3 parts, okay? Well, we need open paren, an expression, close paren, a then statement, an optional else, and after that we have an else statement. Okay? And then on line 2, we also see the parentheses. We see expression, this expression is y is less than z, and then we see the close parentheses. Okay? So by line 2, we see everything up to here. Starting on line 3, what is the compiler expecting? What is that? It's just a statement, right? Any statement will do. It's looking for a statement. On line 3, do we see a statement? Yep, we see a statement. Yep, we see k equals 1 semicolon as a statement. And then after that, it will say, well, optionally we can find an else, okay? On line 4, oh, we did find the else, okay? And then we move forward to the else statement. So now the else statement is on line 5, which is k equals 2 with a semicolon. Is that okay? But the important part is, once you fill up all the parts of a conditional statement or any statement, this entire thing at this point becomes just a statement, because it has all the parts already finished. It finished parsing all the parts already. So now it becomes just a statement. It goes back to here. The compiler goes back to here and say, oh, okay, this is all done now. Okay, are we doing okay so far? Because this is the important part: is when do we say finished and go back to the earlier point. At this point, the compiler says, okay, we are processing the first conditional statement again, and I'm looking for the optional else. Do we find the optional else? Well, k equals 2 semicolon is on line 5, so the compiler is now processing line 6. Line 6 is, what does it spell? Else, right? And are we looking for an else? Well, it is optional, but we are looking for an optional else. So on line 6, it goes back to this else and go like, oh, okay, we are now expecting an else statement. What is going into the else statement? What did the compiler see when it's trying to look for the else statement? It finds the if on which line? On line 7, very good. And what does the compiler do as soon as it sees if as the starting point of a statement? It sets up all the expectations, right? So it sets up the expectation of open paren, an expression, close paren, a then statement, an optional else, and an else statement after that. Are we doing okay so far? Okay? And after this if, on line 7, we see the open paren, we see an expression, which in this case is x is the same as y. We see the close parenthesis. That's on line 7. After line 7, it is expecting a then statement. What statement do we see on line 8? K equals 3 semicolon. Okay? So k equals 3 semicolon is fulfilling the requirement of this then statement. And then what does the compiler think at this point? It has found the then statement of this if. What is it going to do next? Something that is optional, right? Okay? Because it can find an else that is optional. Sometimes it's there, sometimes it may not be there. But in this case, do we have an else? We do have an else. So it finds this else. Then it says, okay, since we see the else corresponding to this if, now we don't have an option but to find the else statement. So it's expecting a statement at this point. On line 10. On line 10, do we see a statement? Okay, we see a statement which is k equals 3, k equals 4, which by itself is an expression, but every time you add a semicolon to an expression, it turns into a statement. Okay? Okay, at this point, are we done? Do we have anything else to look for in this if statement here, the last one? We found all the parts, right? We found the if, we found the open paren, we found the expression, close paren, then statement, the optional else, and the else statement after that. Everything is done. So now the compiler will look at this entire thing and and say, I'll turn this into one single statement, and go back and say, oh, that statement is going to fit this slot here. So that means at this point, the outermost conditional statement as a whole is also done because all of its parts are found. And that's the structure of the code. Now you turn around and you answer the rest of the question. So syntactically, do we have a problem? There's no problem, okay? There's no syntax error with this code here. The next question is, indicate the lines that we will execute in order of reaching. So basically you have to tell me which lines are we going to traverse when this code runs for each of the following test cases. So the first test case is what happens when x equals to 2, y equals to 3, and z equals to 4, okay? So I'm going to use this picture to figure that out, okay? All right. So knowing that x is 2 and y is 3, what is the first question you're going to ask? 2 is less than 3, so where am I supposed to go next? The then statement of the outermost conditional statement. And that's going to ask, is y less than z, right? So in this particular test case, y is 3 and z is 4. Y is less than z is true. Then we go to the then statement of that conditional statement. X gets a value, k gets a value of 1. Do we have anything else to do? We're done. We're completely done because we only choose one, either the then or the else, right? We chose this then, and then we chose this then, which means all the other statements do not apply in this case. Yep.
How are we going to write that on the exam once we find out what line the code stops
You
at
indicate
for
the line
x
numbers.
equals 2? Okay, line numbers.
So you indicate the line numbers, which is going to be line 1, line 2, and line 3 in this case. Just those 3 lines. All right. Well, we are running out of time today. I cannot, continue at this point because I don't want people who actually have something to do after this class to have a disadvantage. So we'll continue this on Wednesday, okay? And please work on your homework assignment because you can do it. It's just that you have to think about all the individual pieces, okay? Don't fold a box in your head, okay? There's no such thing as thinking out of the box because we fold our own boxes first, okay? In the first place, the box was not there to begin with.
I have a question.
Yep.
A NAND 2 gate handles 4 bits of data, right?
A NAND 2 gate will process 2 bits of data and give you 1 bit.